Hi everybody. Today we're going to learn about TypeScript. TypeScript, as you can see on the website, it says that it's a superset of JavaScript that compiles to plain JavaScript. It runs on any browser, any host, any operating system, and it is open source. Let's talk about these two points first. So when we say that TypeScript is a typed superset of JavaScript, it means that it is a strict superset. Which means that if you write normal JavaScript and you just rename that file, rename a .js file to a .ts file, what you get is valid TypeScript. It's a strict superset of JavaScript. Uh, in addition to normal JavaScript syntax, TypeScript also supports some additional syntax which provides typing. Uh, Providing typing, it means that the absence of types in JavaScript, that is, if you construct a variable, it's just a var, and then it can contain integer values or string values or character values, anything. That is considered by a lot of people when they are working on large projects as a slight limitation in JavaScript, that the types are not strict enough. So if you take an integer variable, put some string into it, JavaScript does not fail, right? And there's no compilation stage, so JavaScript simply runs that code, and what you get, the end result could be something that you're not expecting. The guys at Microsoft, they decided that we can fix that. We can have some of the safety features that Java and C# type of languages have. So they introduced TypeScript. Now TypeScript does not run itself. TypeScript is not a language that can be directly interpreted. So TypeScript is compiled into JavaScript, and this process is generally called transpilation or transcompilation. Is the noise less now? Yeah, okay. So what happens is when we write TypeScript code, it gets converted into JavaScript code, and that JavaScript is what actually runs. Now, I mean, so we've discussed a lot. Let's just straight away move over to some code and let's see how it works. Let's just say we have uh, we create a simply new JavaScript file. Let's say hello.js, and we have this function, say hello, and in this function I take a variable name, and I do console.log hello name, right? And we call this function, say hello Arnav, and this file, we can simply run this with Node.js on our desktops, just like this node hello.js. Run that and it says hello enough. So this is how we run simple JavaScript. Now if we want to write this same file in TypeScript, what we can do is, let's just simply take this file and rename that into hello.ts. Okay, uh, convert that to ts, and once I convert that to ts, to run this file, what we need to do is install the TypeScript compiler. So we can install that using npm install g TypeScript. Okay, this will install TypeScript for us. Okay. Uh, what we're gonna do is run TSC. Now, TSC is shorthand notation for the TypeScript compiler. So when you do npm install g TypeScript, you get uh, this TSC binary. With TSC, you can transpile TypeScript code to JavaScript code. You can simply run TSC hello.ts. We run that, and after we run that, you will see that a JavaScript file gets generated out of this. Okay, and you can see that there is no difference in these two files as of now. It's this exact same code. And now you can run this file as node hello.js, and we get hello enough. If your file is not valid TypeScript or it is not valid JavaScript, because JavaScript is a subset of TypeScript, the TSC compiler will give you some error. So like if I write something like int a equal to 10 like this, which is not valid JavaScript, as you know, because JavaScript does not have an int keyword. If I try to run tsc hello.ts, uh, you'll see that you get an error, some semicolon expected, there is line number 15, something like this. Okay, so by using TypeScript, what we basically gain is that we add a compilation layer to our JavaScript ecosystem. So first we write our code, it gets compiled to, in languages like C or Java, it gets compiled to some bytecode or binary code. Here, the compilation target is JavaScript itself. So when we compile that file, what we get is a JavaScript file. Okay, so is the noise problem a little better now? Yeah, Nirban. So every time we run, no, we don't actually run the .ts file. What we do is we run tsc, and to tsc we give the .ts file as an argument. It converts the .ts file to a .js file. Okay. Uh, you can set up some of your IDs, like if you're using WebStorm or Visual Studio. In that case, what you can do is you can configure that to compile TypeScript automatically. For example, in WebStorm, there is this setting, if you put a tick mark on enable TypeScript compiler. In that case, as you write your code, automatically it gets converted on the fly to uh, JavaScript. Okay, guys, just give me a moment. I'll just try it out with a different microphone. So is the audio better right now? Can you just let me know? Yeah, okay, so continuing. So now let's start with adding some of the TypeScript related syntax into our code, which would show us the power of TypeScript. Uh, let's say this name variable, and we want to make sure that this name variable is a string. Okay, so we can add a type like this using Pascal notation. So how does Pascal notation work? Let's just consider it here. If I write that var x is a string and equal to something like this. Okay, now this notation is called a Pascal notation, where in Java you generally write something like this, string x equal to something like this. Okay, here what to do is we create a variable x, and after that we write the type of it, and then we assign it some value here. Okay, similarly, in a function, if we want to assign some variables, some types, what we can do is in this say hello function, we can add this, give it a string type. Okay. Now we just added this string type here. Okay. And we simply just run tsc. And let's take a look at our JS file, what it happens. You see, the generated JS file is not different at all. It is still the same JS file that is generated, because JavaScript does not actually support types. So whatever type we added here, this is only to help us at the development stage, and it is going to throw us some errors at the compilation stage if we try to call this function with something that is not a string. For example, if I write say hello and call it with 10. Okay, you see, there is this because I have a TypeScript extension plugin added to WebStorm. I am getting this error right here in the ID. In addition, if I run tsc hello.ts, you'll see that you get argument of type 10 is not assignable to parameter of type string. This error you get automatically. Okay, the thing is, if you look at the JS code, TypeScript does not fail. Okay, TypeScript will convert your code to JavaScript, and if you run node hello.js, see hello Arnav and hello 10 gets printed just like normal JavaScript should work. But at the compilation layer, you made this function enforce the type string. So when you're compiling this TypeScript to JavaScript, TypeScript will tell you that whenever you're trying to send in any variable that is not in form of a string to it, TypeScript will give you an error. So this enhances your development workflow. It makes sure that you're not using some variable type where it is not supposed to be of that type, it is supposed to be of some other type. Those kind of errors you can check easily at this stage. Okay. So what all we can do with types is, let's take a look at this thing. I'm just creating a new TypeScript file. So we can write types like this: var str string equal to some text. We can write technically when you are trying to write code which is going to be similar to your previously written JavaScript code, you should prefer to use the small letter string, not the capital S string. And what's the difference between the two? I will just show you. If you run say Node.js, and you see you can make something like var s1 equal to new string abc. Okay, and you can write var s2 equal to new string abc. Sorry, let's just see var s2 equal to abc, and if you type s1 equal to s2, they come out to be true. Okay, if I do var s3 equal to new string abc, and if I do s1 equal to s3, you see they come out to be false, because those two are not actually the same object. They contain the same data, but they are not the same object. But if you match s1 to s2, they come out to be true, and if you match s1 s3 to s2, they also come out to be same, because when you are matching an object of this type string to an object of primitive string type, Okay, when you match the two of them together, what happens is JavaScript does runtime type coercion, converts s1 to a primitive string, matches it to s2, which comes out to be the same. If you write s4 equal to abc like this, and if you try to match s2 to s4, see, they are going to come out to be true because s2 and s4 are primitive strings, while s1 and s3 are string objects. Okay, so when you're generally writing TypeScript, you usually you want to use the small s string, not the capital S string, because that's the string you have been using till now in JavaScript. Okay, when you write the capital S string, it is the string which we convert with a new constructor, not the usual string that you have been using till now. So we can create a str like this. We can create var num, which is of type number. You can put either integer into it, or you can put a float in number into it. We can set up boolean types, var bool of type boolean, with the value could be either true or false. Okay, now how do we create an object type if you want to create the kind of variable that we create, like var obj equal to this new object which has a 10 b20 like this. So you can create them of object type, if the primitive object type like this, or what you can also do is, instead of using these kind of types, TypeScript can also infer the type from the right hand side. Now, for example, simply this code right now, if I just run it with TypeScript tsc type.ts, we get a type.js file. You see, it looks like simple JavaScript like this. The types have been omitted from the runtime. Okay, now there's something to be kept in mind, is that in languages like C++ or Java, the strong typing is available to you at runtime as well. In the case of TypeScript, during the runtime, the types are omitted because JavaScript does not support types. So during the runtime, any type related errors can happen. TypeScript will only check your code during the compile time, not during the runtime. You cannot have type safety, obviously, because it's going to run on JavaScript. Now, if you create a variable like this, var mystr equal to some string, and you do mystr equal to 10, and here you will get an error again. Assigned expression type number is not assignable to type string. You can see that mystr was never given the type string, but there is this beautiful property of TypeScript, is that when you're creating a new variable and whatever value you assign to the right hand side, TypeScript will automatically check the type of the right hand side and assign that same type to this variable. Okay, automatic types are applied. They are inferred from the right side. This is called type infer. Okay, so TypeScript supports inferring types. Apart from that, we need to create functions also, obviously. And in functions, there are two places where we need to define the types. We need to define the types where of the variables that are going into the function, the arguments, and we need to give define what type of value will the function return. Okay, so let's take the example of the kind of function that we were building before. We have this function create hello string, and it takes name in form of a string or string, and this function returns a string. Okay, so here we can do is return hello plus name. Now here, instead of this, if we were returning 10 here, you will get an error here, because this function is supposed to return type string and you're returning a number here. It's perfectly fine to return hello plus name here. Now, so here we have a function where we have defined the type of one of the arguments that it is getting, as well as you have defined what is the type of the return statement. Okay, so this is the way we will set up types for our functions. So now let's take a look at these were some very basic examples. Let's look at a more real world kind of approach. So let's say we are creating a TypeScript file that would manage some to-dos. Okay. Now in JavaScript, what we generally do to create a class is that we have something like this. We create a function to do, and there to do is we do something like this dot task. Let's say we have a task here, task and done. So this dot task equal to task, this dot done equal to done. Okay, like this, and then we can create a new to do like this. New to do equal to new to do, and okay. So I created something like this, a new to do, complete this webinar and true. Okay, by the way, just keep in mind, we do say that TypeScript is a strict superset of JavaScript, which means any code that was valid in JavaScript should run exactly as it is in TypeScript. An exception to that is in this case, if we don't use the second variable. Now TypeScript makes sure that if your function takes two arguments, you are taking two arguments here. Okay, so this code as it is written right now here is completely valid JavaScript. There shouldn't be any issues here. Obviously the variable done inside to do will be defined as undefined because we have not sent the second argument inside this constructor. If we run tsc, get our JS file, which looks like this. We should not actually write code like this because this function was expecting a done variable. We have not sent it, but in JavaScript, the variables are optional in nature. You can omit the last variable if you want to, right? So this kind of a code does generate a warning inside TypeScript because TypeScript is checking the number of arguments as well. Okay. Now this is the way we create classes in simple ES5 notation, ECMAScript 5. In TypeScript, what we can do is we can make it a better way. We can use proper class syntax, which is available in ES6, that is ECMAScript 2015 class syntax is available. We can make use of that in TypeScript, and we can write code which looks very similar to Java or C# kind of code. How we'll do that? We will create a class to do. Inside that we will create a constructor. In constructor we will use task, which is a string, and done, which is a boolean. Okay, now here we will do something like this dot task equal to task, but there is no task defined inside this, which means we will have to write something like this. Let task yeah, and done boolean. Okay, so we have these two variables declared, task string and done of boolean type. So now we can do this dot task equal to task, and this dot done equal to done. Okay, and now we can create a new to do like this. Let to do of type to do equal to new to do, where complete this lecture false. Let's look at the JavaScript that this kind of function generates. See, it generates a very similar thing. It creates a function basically it creates a IFI for that immediately invoked function, but other than that it is the very same code that we had written earlier. It generates this kind of a function to do, which takes task and done, this dot task equal to task, this dot done equal to done, and it returns this. One thing that you can do is we can make this private and we can make this private. Okay, how that will make a change is, now we can create a public set task done function which returns void, because we are not going to return anything from this function. Public set task done void, and here we can do is done this dot done equal to true. Okay, now to do dot task equal to something else we want to change, and this does not work. It says private member is not accessible here, and here if we actually run this TSC code, and if you try to run node todo manager.js, you'll see that at the runtime, setting anything as private does not affect the way the JavaScript code runs, because in JavaScript the concept of public and private does not exist, which means that this is perfectly fine. So if you can see a proof of that, we can do console.log todo.task and then do todo.task equal to something else, and then we can do console.log todo.task. Okay, transpile this file and run this. So you see that the task variable, it is able to print it even though it is private, and we are able to see it after it being changed as well. So this runs because TypeScript only shows you these errors, but it does not, TypeScript will not stop you from actually transpiling the file into JS. Okay, so in TypeScript you actually do not have something called compile time error. Everything is compile time warning only, nothing is compile time error. But at least at the compile time you see that there are some mistakes with your code. You are using the code in a way you did not design your class to be used. Okay, but if you use if you write todo dot set task done, calling this variable is perfectly fine. Okay, so the major takeaway out of here is that TypeScript will show you some errors if you want to make sure that after a to-do object is created, you do not want to let anyone change the task name. So you can make that variable as private and not create a getter or a setter for that. And in that case, whenever you try to directly change the task variable, you will get a compile time warning. But if you still want to use it, you can still do it, because it is a strict superset of JavaScript, and whatever is possible in JavaScript, it is still possible here. Okay, okay, so now next thing that you're going to see in TypeScript is the concept of interfaces and how interfaces can help you out. So let's say I create an interface. And inside this interface, food options, what I'm going to do is write certain things that taste should be a string. It should have a color, that should be a string, and let's say we have can eat raw, and that is going to be a boolean. Okay, now let's say we create this function, or let's say we create a class food. Okay, and inside the constructor, what we do is we take options as food options type. Okay, how is that going to help us is that if we now try to create a food object, if we try to create, say, or let's say, yeah, as soon as you write new food, you will see that inside the constructor you will have to send an option object of type food options. So if you create an object like this here, we will need to send taste as, say, sweet, okay. Now this way, what we can do is, if we want to create an options object which contains the options which are required to create a food, uh, we can make sure that all the required options are available to us whenever somebody is trying to create a new food item. Now if we do not provide the can eat raw to it, then it is going to give us an error. Okay, in many places in JavaScript and many libraries, we will see that a lot of functions or a lot of constructors, they take arguments in form of an option object like this. So this is really helpful because you don't need to use variable argument numbers, or you don't need to add multiple variables into that function. You can simply send a single object. It will contain all the options of it. Okay. Now the funny thing about interfaces is that interface is a concept that simply exists to enforce some kind of types. Now interfaces, if you actually run tsc on this file, if you take a look at interfaces.jsc, the interface itself is not visible here anymore, because what would be the use of this interface inside my JavaScript file? Because this interface was only there to make sure that whatever option I send in contains taste, color, and can eat raw. In JavaScript, at the runtime, neither the interface exists, nor we can check whether all the variables that we require are available to us or not. By the way, let's say we have this thing. We do is this dot taste equal to, we have to create this thing. We have to create taste of type string, color of type string, and can eat raw of type boolean. So this dot taste equal to options dot taste, this dot color, options dot color, this dot can eat raw, okay. Now we've done like this. Now let's say we want to have this thing that if the can eat raw option is not available to us, we will directly set it to false. Okay, by default, all our food we cannot eat them raw. In that case, we don't need to enforce the availability of can eat raw to us. So we can use this question mark notation. We can write can eat raw question mark boolean. Okay, what that helps us do is we can write let say omelette is also a food. Here in the options object, let's say taste is salty, and now you see you can omit can eat raw and it is still valid. There is no red underline out here. That is possible because can eat raw was optional in nature. That is fine, but what would be the value of can eat raw in omelette if you log the value of omelette dot can eat raw? So let's try that out. Just so it's coming out to be undefined because we did not send anything to it. If you want to make sure of that, we can obviously do is that options dot can eat raw, or you can just use the ternary operator options dot can eat raw if it exists. So then it is options dot can eat raw. Otherwise, it is going to be false. Write it like this. Is going to be false, so we have created a default value for it using this notation. Okay, so Anirban, are you asking about the significance of the options object itself or the significance of the question mark operator? Because the significance of using an option object is that we can create constructors which take a single option object, and if you have used libraries like, for example, Sequelize, inside Sequelize we send an option object. We do not mention the database name, username, all of these. Instead of writing them separately, we can send an option object, and inside the option object we can define all of them. And in that case, the order of the variables do not matter. If you use an option object, you can write that in this form as well, right? You can write color first, taste after that, and can eat raw after that. You can write it like this if you want to. So that's what the significance of the options object is. And in many libraries, you will see constructors use an option object instead of separate variables. As far as the question mark operator, like you can see, it makes that variable optional in nature. That is, if you want to, you can define it. If you don't want to, you can leave it out. So you can define can eat raw if you want to, and if you want to, we can leave it out. Now, even if you define it, it has to conform to the type boolean. If you write it as some string, you'll get an error here. Okay, so you'll have to use a string here, boolean here. The other option is you can let it be undefined. So it can, by option, it means that it is either a boolean or it can be undefined. That's what the significance of the question mark operator is. Okay. So now the next thing we're going to see is the concept of generics in TypeScript. Generics is something or in form of templates you are well versed with in other object oriented languages. Just we can create an array list like this. Array list of string in Java is like this kind of a syntax: array list angular bracket string, which means an array list inside which every item is going to be a string. Okay, so what is the point of generics is, let's say we have this function. So you have this simply function called echo, and it takes a type t. Okay, and inside that there is an argument of type t, and this function returns t. Okay, and this function, let's say we simply return is we simply do return arg and say +1. Okay, or just let's say simply return arg. And now what we're going to do is say we call this function echo with number type, and we send 10. Okay, and let's say we have variable with us, let x of type number. Now we can set x equal to echo arg10 like this. If we send x equal to echo you see this gives you an error as of this state, because when you call echo, if you set the generic type of echo as number, which means t becomes number, which means this number this function echo must take an argument of type t, which means this must take an argument of type 10, and it must return and return something of type t as well. Okay, so which means if you write echo generic type number 10, that means this number must take number as an argument. If I write a string here, I'm going to get an error, so I have to put a number here, and the return type is also going to be number, so that I can assign to x because x is of type number. Same line if I write here like this. Now here you have a problem because this gets underlined, because this echo, if I write say let y of type string, and if I assign this value to y, that's fine, because this echo call returns something of the type string, and this echo call returns something of the type 10. Okay, now again if we run it with if we just convert it to JavaScript, so see here, the entire concept of generics exists in TypeScript only. When we convert that into JavaScript, nothing of that exists anymore. The generic types are completely omitted, and it's simply function that takes arg and returns arg. But when you're writing in JavaScript, you can make sure that when a function is returning number, it is assigned only to a number variable. When it is returning string, it is assigned to a string variable. You can enforce that strictly in TypeScript because you have the facility of generic types. Which also means that we can create something of this type. Let's say we create a class array list of type t. Okay, and this has something like an array. Okay, let arr of type t. Okay, sorry, you don't need t to define it. So there is a private ARR like this, and then let's say we create a public get function, okay, which returns a t array, okay, and returns ARR. So return ARR. So simply have this constructor which creates this dot ARR as an empty array, right? And now what we can do is we can create let string array of type array list string equal to new array list. Okay, we get this, and then if we take string array dot add, if we call, we can only add strings here. We cannot add a number into this thing. Okay, now why is this important is because if you convert this to JavaScript, technically this kind of code is not a problem in JavaScript. Like you can see that this array list function, what does it? Simply this dot push item it does. Okay, and if I do string array dot add number, we know that in JavaScript you can do something like this. You can create ARR equal to an empty array, and then ARR dot push, you can do a string, and then ARR is like this, and then ARR dot push, you can do a number. And so in ARR there is a string and there is a number. So you can create heterogeneous arrays in this thing in plain JavaScript. You can do that, but similar to Java, you can create your own array list class like this, which has a generic type t, and you can make sure that people are not adding something that is not a string into your class. Okay, so this is one advantage that you have of generics, is that you can use them just like you use generics or template in C++ and Javas. Okay. And yeah, obviously you can have multiple of them. You can add so this class has three generic types, t, u, and v, and you can use, say, t as one type, u as one type, and v as another type. The three generic types are completely possible, not an issue. Okay. Another really nice thing that JavaScript, TypeScript brings to JavaScript is the concept of enums. So enums, just like enumerator types are in strongly typed languages, you can create an enum. Enum could have a set of predefined values and nothing outside of that. One such example would be coming back to our this class to do example that we had. It had task of type, say, string, and let's say I add I create enum to do status, to do status could be new working completed abandoned. So you can have new working completed and I think let's just use fresh here because new is technically a keyword in JavaScript, so we should not use anything that is a keyword. So let's say there is fresh, working, completed and abandoned, and these are the enum types that we have. And now we can set the status here as to do status, right? Then we create a constructor. In the constructor we take task of type string, and we take status of type to do status. Okay, and we do this dot task equal to task, and this dot status is status. So now if you have to create a new to do, and let's say it's in a working state, so I can add oh sorry, I'll have to add the enum types in this format, to do status dot working. Okay, so this way we can set up enum types, and this to do will have to do status as working. How do enums reflect in the JavaScript code? Let's take a look at that. Let's just run TSC on enums. Let's see what this generates. You can see this creates a little convoluted stuff. It creates something called to do status, which has to do status fresh as so what this has created is it has created let's just run this code and I'll just show you what this has created. Okay, just going to print the value of to do status, and we're going to see what this is actually. Node enums.js. So it has created a reversible list like this. Okay, it creates 0 is mapped to fresh, 1 is mapped to working, 2 is mapped to completed, and 3 is mapped to abandoned in an object. It's a plain JavaScript object. The reverse mapping exists: fresh to 0, working to 1, completed to 2, and abandoned to 3. Okay, so technically if I print the value of to do dot status, the to do that we have created, if we print the value of that and if we try to run this code, you see the number comes out as 1 because working is not like working is nothing. I mean, working is simply a string. It is only used to create a mapping, and the actual data is saved in the form of fresh as 0, working as 1, completed as 2, and abandoned as 3. These are the 4 states that are created for to do status, and you can select any one of them. So you can refer to them as to do status dot working. But what actually happens is internally an object gets created like this, where all of these variables are available. So 0 is mapped to fresh and fresh is also mapped to 0. Both the things happen. Okay. Now, if you don't want these mappings, if you want different kind of mappings, you can take advantage of that as well. How? You do fresh equal to fresh right. In this case, and let's just print the value here. So the value is now string working. Just because I created the enum in such a way that they are actually set as string values instead. By default, all the data inside enums will be assigned as 0, 1, 2 and so on. If you want them to be assigned some other data, if you want them to be assigned as strings or some any custom data that you want to, you can do that as well. It's completely up to you. Okay, and you can use a shorthand notation in this form. If you create the keys inside them as strings in the first place, they won't be set to numbers, they will be created as strings in the first place. Okay, this just in case you're wondering, this is different from writing it like this. Okay, writing working like this means working equal to 1 like this, but if you write string working, so then working is the enum key as well as the value inside that key. Okay, so I guess this you're able to understand how enums work in TypeScript. Okay, we can create some complex types in TypeScript as well. Let's talk about what are complex types. Technically speaking, nothing very different. We can say create um, type so we create a type called num or str, and we create the type like this. The type number, use the pipe operator and use string. So that means that this is a new type, and this type is something that can either be a number or it can be a string. When we create it like this, what we can do is we can call greeter, and we can call it with a string. We can also call greeter with a number, and both are valid. If you try to call greeter with boolean value, you see you'll get an error here. It's because num or str is a new type that you have created, which can either be a number or a string. So you can create complex types in the form of this. Okay. So we've seen a lot of TypeScript, the basic definitions of that. A lot of that we see here. Let us do is let us now try to create our own project and see how TypeScript can be of help to us in that. Okay. So let me just close this project, and we will start a new project. Okay, so here we're going to see a proper project setup, full-fledged project creation using TypeScript, so that we can automatically, when we run our project, everything gets transpiled automatically, and it runs also automatically. All of that stuff happens. So obviously, first steps, like we do npm init, create a new project. Uh, Yeah, so we get a package.json, and now what we're going to do is we will create a src directory here, and we are going to create a dist directory. Okay, an src and a dist. Now all our TypeScript code we are going to write in our src folder, and all our distribution code is going to go, that will go into our dist folder. Okay. Um, Let us just start with a simple Express application that we already are aware of, and we know it's very easy to create one. You can go to expressjs.com and you can build one simply like that. So you do is npm install uh, Express. Right. So let's do is create this file here. I'm just starting with a JavaScript file, simply JavaScript file, server.js. Okay, and here yeah, this basic Express server, the same stuff that you can find out on expressjs.com, just the quick started guide that you have. The normal Express server, just we want to use TypeScript, and we want to make sure that it all integrates with our npm, and it all runs automatically. We will simply have a single command to transpile all our files. Earlier what we were doing is we were giving a file as an argument. Now in our project we might have more than one file, and so on and so forth, right? So let's do is or let's say, let me write some more data here. Let's create this thing. Let's create some roots here. And inside roots we create teachers. Inside teachers we create another one, students. Okay, and these are express roots. They work like this, const So here we have an array of teachers. In when we do root.get, we do is res.send teachers, and let's say create something. Oh, sorry. In case of students, what we do is create students like this, and okay. So these two routes we have created, and these two routes we can set up on our server like this. And we can do app.use students student root, and app.use teacher root. Okay, so that's how a server looks like. We can do node src slash server.js running on this place. Visit that. It says hello world when we view the root path. If we go to slash teachers, oh sorry, this is the teachers root, and so the students root, they look like this. Okay, now we'll just use TypeScript in this project, and how we're going to do that is, first of all, we're going to install these are going to be our dev dependencies, because we need TypeScript to develop this app, but to run it we won't need TypeScript, because we will simply be running it from our JS files that are going to be transpiled out of TypeScript. So we need TypeScript. Okay, apart from that, we will also install something interesting. We will install this package called @types/express. What is @types/express? Let's take a look. npm.js @types/express. Okay. This is basically type definitions for the Express package, and there is this very interesting repository. It's maintained by the TypeScript community. There's this repository called Definitely Typed, and Definitely Typed produces type definitions for many JavaScript files. So when you're using a library, having a type definition for that library is really helpful. For example, the rec object is of request type, the res object is of response type. What are the functions and variables available inside request? What are the functions and variables available inside response? These are all defined in these type files. So there are many such type files available, and we're going to use types/express. Okay. Okay. To start with, what we're going to do is we will now add a tsconfig file. Okay. A tsconfig file defines how our source is going to be compiled to TypeScript, from TypeScript to JavaScript. A few things we need to change in the default tsconfig file is that we want to add a base URL. Our base URL is going to be src. Okay. Our out directory is going to be dist, and we are going to exclude node modules, and we are also going to exclude dist because these two folders are not going to be transpiled because they already contain JS code, and we are going to include SRC folder. Okay. So SRC is included, node modules and dist are all excluded. You can either include SRC like this, or you can write files src /star /star, which means all files inside SRC up to any depth of folder. /star means any folders inside any subfolders, any files inside any subfolder inside SRC. So that's what this means. So you can either use it like this, or you can use includes include SRC. Okay. So our TS config is basically set, and now we can do is start converting our first of all, let's add a package.json script. Let's add a script here, build. What this build script does is it is going to run tsc and simply that. Pre-build, we can add some stuff that happens before build. rmrf dist folder. Okay, so let's do npm run build. You can see what happens. Okay. So I'm really sorry because TypeScript can support simply copying JavaScript files as well. Right now, my SRC file does not have a single JS file. Okay, so it was we need to write this allow JS as true. What this allow JS means is that TypeScript will, if it finds any .ts file, it is going to convert that to JS. If it finds any JS file, it will simply copy that. So let's run this. So my dist folder now has a server.js. Now this server.js, and there are roots, and inside roots, you see these code are actually the very same as the one we have written inside our SRC folder, right? If you look at SRC server.js, and if you look at dist server.js, it's just the empty lines have been removed. Another extra thing that TypeScript does is, since we have set our target as ES5, all the code that it converts it into valid ES5 syntax. Although I have been using const, and const is available in ECMAScript 6. By default, Node can run const. Most browsers can also run const, but ES5 supports only var, so it converts to that. If you write your target as ES 2015, in that case, when you build, in that case, you literally see the code is exactly the same. Spaces have been removed, but other than that, it's the same code. Okay. Let's start now. The beauty of TypeScript is we can start with this stage where there is no change to our code, and incrementally start adding TypeScript support. Okay. So what we'll do is take server.js and we'll convert this to server.ts. Okay. Now it has been changed, and